Right guys, a quick vodcast on the carbon cycle, and what I wanted to do is very quickly just take you through it on the basis that there's three main processes that you need to know. The first is photosynthesis, in which carbon dioxide is taken in by plants and trees and sometimes algae. The next is respiration, which both animals and plants do, as well as bacteria that are decomposing dead organisms. And the last is combustion, which is in factories, cars, anything which burns carbon. Coal is a classic one. Carbon plus oxygen goes to CO2, and this pushes this into the atmosphere. So three processes: photosynthesis, respiration, and combustion are going to form the basis of the carbon cycle. So what is the carbon cycle? Well, as I said in our lesson today, the world is not making any more carbon. We are surrounded by space, which is a vacuum. And other than the odd meteorite, which might have produced or got through some carbon as it hit the Earth, we're not making any more. And so all of the carbon that is in the world, tied up in carbon dioxide in the air, calcium carbonate in limestone, in you and me, in all animals and plants, which are carbon-based, all of that carbon is constantly being recycled. And it's been going on for billions of years. And so in terms of the carbon cycle, it's important to know that everything needs to be recycled. And in this kind of circle of life, a bit like, say, the Lion King, it's a circle of carbon. We've got carbon dioxide in the air, which is probably, I would say, the one that is the real driver. Although the air is only a very small percentage of carbon dioxide, all of the so much carbon is held in the air. And what we need to do in order to recycle it in the Earth is fix it in one place. Turn it from a gas, the carbon is locked up in a gas, into a solid. And the legends that do this are the plants. The plants are able, through a process of photosynthesis, and right now the equation for photosynthesis should be really running through your mind. Carbon dioxide plus water, using sunlight, goes to glucose, which is a carbon-based sugar, and that's where the carbon goes, plus water. Okay? The water comes out of the leaves in transpiration, and the glucose is used by the plant as an energy source. And so we've got carbon from the air into a solid form. We then eat the carbon, and animals will take the carbon that the plants have fixed and eat it, and then we burn it. And in that process of burning sugar, a process called respiration, once again, the respiration equation should be going through your mind. Glucose plus oxygen, which we breathe in, going to carbon dioxide and water, with the release of energy, which we use to grow, to move, to do all of the things that our cells need to do. But the byproduct of that is carbon dioxide, as I've just said. So can you see here this mini cycle that's going around? Photosynthesis, carbon dioxide taken in, respiration, carbon dioxide out. Respiration out, photosynthesis in. Respiration out, photosynthesis in. And this is going round and round and round in all living organisms. Remember Mrs. Graham, the R for anything living is respiration, which does bring me on to this point. Plants, like trees, respire as well. They are also responsible for producing, and we can see here, carbon dioxide from respiration. They are respiring day and night because they're alive. But in the day, they do this photosynthesis. So never forget that plants respire too. All animals certainly do, but we have no way of getting the carbon dioxide into a fixed form like plants do. So photosynthesis, respiration. Photosynthesis, respiration. Look at that lovely cycle. Now, the other things that happen here are that there's respiration done by other organisms, which are important here, and they are the bacteria and decomposers. They're alive, so they respire. And when an organism dies, decomposers come in and break that organism down. And they break it down to its constituent parts, which means that some of the carbon leaches into the soil. But two other things happen which are important. Firstly, the bacteria are alive, and so they're respiring, so carbon dioxide goes into the air from respiration from bacteria. But secondly, parts of the dead organisms, and you'll know this from things like sea life and also trees, can be fossilized. And the fossilized forms are when layer upon layer upon layer upon layer of pressure as a result of dust settling on the Earth over hundreds of million years. Think about the pressure that would form, condenses this living tissue, these trees and predominantly marine life, into oil and coal. And these oil and coals are hugely carbon-based. So instead of carbon being in the air, it's locked up in these crushed oils and coals. And in the carbon cycle, there's a way that we can unleash that carbon, and that is by combustion. And so when we take coal from the ground or oil and we burn it, carbon plus oxygen goes straight to CO2, and that goes into the air as well. So there we've covered the three main processes. Photosynthesis and respiration have their own little almost cycle going on. Carbon dioxide in to fix in sugar, carbon dioxide out during respiration. And then we've got, as a result of fossilization, we've got the ability to burn fixed carbon, which is in coal and oil, which directly combines with oxygen when we burn it to produce carbon dioxide. Just a couple of points about that, of course, which are things you should think about. That happens in factories, in power stations, and in cars. And we all know that that may lead to global warming. Well, I say may, of course it does lead to global warming. And that is difficult for us because it means that the average temperature of the Earth is rising, and that creates problems and changes which we're now seeing the repercussions of worldwide, which we should know about. So, that is the carbon cycle. We're not making any more, and through a process of photosynthesis, which takes gaseous carbon and fixes it, respiration, which takes fixed carbon and gasiates it, if that's a word, and combustion, which takes fixed carbon in fossilized form and burns it. We have this cycle that goes around and around and around, and you've guessed it, and around.